Hello everyone, today I am going to deliver a lecture on introduction of Prestress concrete, which is PSC, and three concepts of Prestress concrete. Okay, firstly I will say the definition of the Prestress concrete of PSC, and second one comparison between RC or reinforced concrete and Prestress concrete, and three concepts of Prestress. It's the first concept, second concept, and third concept, and consequently method concept. And then I will classification. I will give the deliver the classification and type of the Prestress concrete and stage of loading of Prestress. Okay. It will be this. Okay. So let's start the definition of Prestress. I will say I will follow the this book Design of Prestress Concrete Structures, third edition by T.Y. Lee. This is the reference. Okay, so let's start the definition at first. So Prestress concrete we have been seeing here. The Prestress concrete in which there have been induced internal stresses of magnitude and distribution that the stress ruling from given external loading and counteracted to desired degree. And in reinforcement concrete member, the Prestress is commonly introduced by the tensioning by the steel reinforcement. Okay. There are three concepts. We can see first concept, second concept, and third concept. The first concept is prestressing to transformation concrete into elastic material, and second is internal resting moment, and third is prestressing to achieve load balancing. Okay, we will see the detailing with method example. Okay, so we have completed this. Now we will see the comparison between RC and Prestress concrete. Okay, so let's see here as the difference between RCC, reinforced cement concrete, and Prestress concrete. So load carrying capacity comparatively low in RC, very low, and the load bearing capacity is very high in Prestress concrete, and deflection is more, the deflection is less, the shocking resistance ability is low, and the shocking resistance ability is high. So long span is applicable, long span is not applicable, long span is applicable, and sulfur is greater than Prestress concrete, and the sulfur is much less than the RC concrete. It is expensive, it is economic. So we can see the Prestress is very useful in comparison between them. Okay, so we have completed this comparison. Now we'll see the three concepts. The first concept is prestressing transformation concrete into elastic material. So we will see here the classification type of the prestress. We will see the later. That's why it is crossing, and we will see the stress loading. Okay, this is the first concept, the prestress transformation concrete into elastic material. This concept treat concrete as an elastic material, and probably steel is most common view among the engineers. And then prestress concrete is essential concrete which is transformed from the brittle material into elastic material one by the free comparison given entry. And then concrete is weak in tension and strong in comparison in compress, so that the brittle concrete would be able to withstand the tensile stress. And fourth one, the criterion of the no tensile stress was born. If there are no tensile stress in concrete, there can be no crack, and the concrete is no longer brittle material but becomes an elastic material. Okay, so we can see here the stress distribution across concrete and prestress concrete section. We can see here the concrete concentric tendon here and the force. and a CG is given here. The CG, the beam pre-stress and loaded. So you can see here, due to pre-stress F as in the pre-stress is F already -1, as we know that it is not compression, it is tensioning, that's why minus F. And then we know the due to external moment, so it will be my by I. So external moment you can see here, so it will be my by I. So so due to pre-stress force, it will be act stress force per area, and due to external moment it will be stress mc by I. So these two stress, if we sum this, then it will be minus a by a plus minus a by I. This is due to force and moment, it will be like this. Okay, so second one, we can see the stress distribution across the eccentric pre-stress concrete section, and these are the concentric tendon, and now we'll see the eccentric. So this is the CG, and this is the CG of concrete, and this is the CG of steel. Okay, so eccentric tendon we can see here. So being eccentric pre-stress load, so you can see here, this is the distance between CG of concrete and steel is E, is given E. Okay, let's see, there is a three type of stress we will see. The stress due to pre-stress direct load effect, so we've been seeing this stress is effect in direct load, which is stress F minus A, and another stress due to pre-stress eccentric load, so FEC divided by I, and another one in external moment. So if we summarize 3, then we can found minus A by A plus minus FA by I MI by I. So it will be due to eccentric stress of external moment. So you can see the one portion is coming here extra, which is due to pre-stress eccentricity. Okay, so the first concept is the pre-stress transformation concrete into elastic material. So now we'll see the math example of first concept. This is the math example. So let's see. The pre-stress concrete rectangular beam 5 millimeter by 7.5 millimeter has simple support is 7.3 millimeter, and it is loaded by uniform load is 45 kilonewton per meter, including its own weight, is given figure below. So figure is given below here. The prestressing tendon is located as shown below. We can see the prestressing tendon is given below, and the eccentricity we can also found here. And the prestress tendon is located as shown below, and effective prestress of 1620 kilonewton. So we can see produce an effective prestress load 1620 kilonewton. Okay, so complete the fiber stress in the concrete at the mid span of the section. So this is the mid span. So we can see here the prestress which is load is 1620 is checking force, you can see, and the 45 kilonewton is UTL, and the length we can see 7.3 meters, and we can see the CGS of the given here, and another is the 10 CGS is given. So we can see the S section is 500 and 750. So as the location of the tendon is given 230, so we can calculate the E value. How we calculate E value? So we know that this is the 700 divided by 5, and if we divided by 5, if we deduct this below 230, then we get 145. This will be the distance of the CG of concrete to the CG of steel. Okay, so let's start. So force is given 1620 kilonewton, as we can see here, the effective prestress forces, and area is also we can found here 5075, and E is we can found different between CG of concrete and CG of steel. and moment of inertia have been found dp by 12 as we have been found this from this below, and y we have been found d by 2 as d is given 750, and essentially as we have been seeing, this is the we can see the uniform simple supported beam, that's why w square by 8 and found this moment. So now we can see the stress. We know the three type of stress we have been seen here, as this is the eccentricity, as we have been eccentricity, that's why the three type of stress will be produced, the direct force stress and eccentricity and moment. So this three type of stress will be induced. So let's see here, why minus f minus, because this is the free stress, that's why it will be jacking force, that's why it will always minus. If the force is compression, then it will be positive. Okay, so in the Prestress it will be always be minus f by f minus f e by I and I, plus minus m by I, and computing this, putting this value and found this value. For top fiber, as we know, minus f minus fi by I plus fy by I and minus my by I for top fiber. So how we calculate here, and for bottom we have been seeing the my by I is plus, and minus will be fy by I. So if we go to the top fiber, this is the top fiber. So we can see for top fiber three type of load. This is the forces load, this is the eccentricity load, and this is the moment load. Okay, so for top we can see this is the positive, that's why it is positive, and for moment we've been seeing this is the top is in negative, that's why we've been taking negative. In this way we calculate the top fiber. Due to Prestress, we have already seen here that due to eccentricity it will be positive, and due to moment it will be negative, and the force is always negative, so there is no. So we have been seeing that three type of symbol we have been used. So in the same way we have been using minus below, we have been for due to stress load, and we can use minus as we have been seeing the eccentricity, due to eccentricity this is the minus or negative value, and due to moment it will be positive value, we can see here at the bottom as we can calculate the bottom. So we have been found minus this value for top fiber and this value for minus. So these are the stress diagram of final. Okay, so let's see another example. So mid span, this is the mid span. The value will be same as we've been found for top minus 7.5 and bottom minus 2.5 or 9. So we can see another example where we can calculate the stress from 2 meter from bottom left. In the previously we have been calculated the stress at the midsection. Now we'll calculate at the 2 meter from the left. So what will be happen? So the same and the curve and z section we have to calculate. Okay. So same dimension is same, everything will be same. Okay. So let's see how we calculate. As we have been seeing here, as we know, it is taken from 145. So we know the 145. This is the one how we calculate. This is the eccentricity of 145. So 145 millimeter. So we know that the 2 meter and has 165. This is the it will be it will be half of the total length is we know the 7.3, as we can see 7.3. Then what will be value of this value? This value will be 7.3 divided by 2, and we have categorized in this way we can found 3.65. And as we have been found this value 145, how we calculate 145? This is the eccentricity. this value what is intensity. So we can see this as the increase intensity. Okay, so we have found here 145 intensity. And what will be the value of x? This value, what will be the value of this x? So this value will be from the similar triangle we have been calculating here 145 and minus will be 3.65 equal to x into 1.65. Okay, and in this way we calculate 65 millimeter from bottom. Okay, 3.65 how will calculate 3.65 to 10 to the power 6 and how will calculate 1.65. These are the nothing, these are the length, these are the length. 3.65 is a millimeter, meter to millimeter, and 1.65 is this length. So these are the similar triangle calculated. So as our first eccentricity was 145, now we have been found to 0 minus 65, which is new eccentricity 165. Okay, and now we are doing the shape diagram as we have been found all the value as we have been seeing from previous math. You can see here 45 kilometer is UDL load. So it will impose the 45 UDL load and 7.5, and it will be divided into two, which is 165 is upward. So taking the 165 upward and 74, and then on 65 and it will be 0. And in this way we can calculate the bending moment diagram. This is the bending moment diagram we can see here 238.5 and maximum bending we can found 299. But we can use the formula for bending moment W is capital A, and for getting the maximum moment. Okay, so this is the maximum moment we found. So F is given on 620 kilonewton and converted to Newton. And eccentricity, our first eccentricity 145, but when we have calculating the new eccentricity for this section, so eccentricity is taken from this eccentricity, which is 165 kilonewton, and moment we are taking not maximum moment because we are calculating from this section. That's why we are taking this moment 138.5. And A is remains same, and Y is remains same, and IY also remains same as we have been calculating in previously. So that's why I and Y we are not calculating again. And stress, now we'll calculate the stress. So what the major change? The major change is moment. So we are not taking this moment because this is the maximum moment, and we are taking this moment because we are calculating this portion. That's why we are taking this moment as well. So in the same way we can calculating the stress at top and bottom. So this is the top and bottom. So you can see the top is less stress and bottom we get the more stress as from this section from the left. On the other hand, if we calculate the mid section, then it will be top will be getting the more stress, as we can see in the previous diagram. So this is the more stress, where this is the middle column, middle at the middle point. Okay, so let's see. This is the completed. Now we can see another second concept, which is prestressing for combination of high strength steel with concrete method. Okay, and this is the second concept, the internal resistance couple method. So you can see prestress for combination of high strength steel with concrete. So it will internal resistance couple method. So you can see here that we are taking the left section only. You can see this is the T and this is the T and this is the C. So difference between T and C value is A, and the moment is between. So as we've been know F equal to stress minus A and F minus A by E. is found in the distance between T and C, and if we detect the eccentricity, then we will find the actual value of A, and it will provide it by Y. So and we can see C into A, which is C into A equal to T into A. So we can call this moment also. So A is a moment as you know here from this diagram is eccentricity and T is due as usual. So what is the coming from this? The coming from external is here. Okay, what is A? A is a momentum, and we are deducting A minus Y because this is the internal resistance couple method, which we can call the Prestressing for combination high strength steel with concrete. So that's why our A we are deducting minus E by A. Okay, so let's see. And the Prestressing concrete rectangular beam we have been the Prestressing concrete rectangular beam 500 by 7500 as a simple span is 7.5 meter and the located uniform 45 and include on wide and Prestressing load is located and shown and produce the effective stress force 1620 kilometer. So all the remain are the same as the previous math example. All the data are same. We have been used the 3. So solve this problem by applying the principle of internal resistance couple method. So we'll be using internal couple method. So let's see what will happen. So all the data remain same as usual. So we've been seeing the CMT is given 1620 and CG of the concrete is given. So let's start. Y equal to T by Q and found force is given 1620 kilonewton. We convert into the Newton as found, and I is remains same, W equal to remains same. Since T act as 230 millimeter, how we get this is the C. Okay. As the profile is given here, so we can see here CMT at 230 millimeter from the bottom. So T, you can see this is the T value is found here 230 from the bottom, and C must be acting 4-5 millimeter from the top. So if we detect from here, then we can find C 4-5 millimeter from the bottom. So E will be what will be D divided by 2. So this is the D total D will be made 475 divided by 1235. How will get 23? 23 is given in example, which is given in question 235 in the this section of distance between top to the T, and found 145 millimeter of E. The difference between CG and T or CGS or C is given. Okay, so now we'll get the as we can see in the in this formula C into L to T into A equal to M. So from this we can find in A equal to M by T. So in this way M by T you can find 185. So this is the value of A. So it will be important how we get the value of A. So the important is how we get the C 230. 23 is nothing but it is given in question. Yeah. You can given in practically you can use this 230 millimeter from bottom to the T level. Okay, so in this way we will calculate, we will found here. Now we will calculate now using this moment this internal resistance couple method, using this formula and using this value we will found in how we get M by T. This is the M by T. How we calculate the E is T minus 230 Q3 is nothing but is given, and found this below. From top we have been seen 5.7, from bottom we have been found 2.3. So we've been seeing as usually from diagram we've been seeing the top is getting the more stress and bottom is less stress at the midsection, as the same result we can found. This is the same result we can found from for the first concept, and second concept we have been seeing the same result. So if we go to the first concept math example, so we've been seeing here we are using this first concept method. Compute the stress concrete at the midsection. So we can found this value, which is at top 5.7 and bottom 2.94. So if we go to the second section, second method, if we use the internal estimate method, then the same result 5.7 and 2.94, the same result we can found. So now these are the complete ones. Now we'll go to the third concept, which is prestressing to achieve load balancing, and the math example. Okay, this is the third concept, with the prestressing to achieve the load balancing. Okay, let's see. This is the example we can see. The solve the problem in example as the same dimension we can use. We have used on the math example concept 1 and 2. The same dimension we can taken and same load we can taken, but we have to solve by the method of balancing, take the concrete as free body and isolated from the tendon. Okay, so it means so stress we have been know as usually force per area into MY by I, and found this value, and top 5.7 and bottom -2.5. As we can see, the same result we can found at the concept 1 and 2. But how we get the moment? So moment we've been seen here, mv divided by w square by a. So how we get the w? These are the vital question. So w is nothing but w we've been found w will found w ultimate, w minus w balancing. So how we calculate the w balancing? This is the diagram we have been seeing. This is the 45. This is the 45, and w is internal resistance. So we can found 8 Fe divided by L square. So in this way we can found 35 km per meter. These are the w balancing. So w balancing plus w ultimate will be total w, which is the applied force here. Now if we deduct the w balancing from the total w, then we found the ultimate UTL, which is 9.65. So these are the very important how we calculate the w. So we're taking this w, which is w square by 8, which is and found 64 km per meter. So this we can see the balancing method. So all the parameter and all the dimension are the same. So these are the concept we've been seeing: the first concept, second concept, and third concept. And LBD, L we've been seeing 7.3 millimeter, and it will be 7.300 millimeter, and B was 50 and D was 70. And third concept, all the dimension of the same, and UTL the 45 kilometer, and all the UTL we can see 45. And the stress at the top, how, and the first concept we have been from 7.3, for second concept 7.5.7, and third concept 5.7. Stress at bottom, what, and minus 2.94, minus 2.94. So all the if we compare this result, all the result are same for first concept, second concept, third concept. The LBD is the same, UTL is same, stress, these are our result. The result also same. The result is also same, but we can use the different method, different formula, but the result would remain same. Okay, so we can see here. Now we can see here another example for load balancing method. The simple supported prestressing concrete rectangular beam is given 350 mm by 500 mm, has a span 10 meter and is loaded by the uniform load. By the way, so we have been found this three concepts. We go to the square. These are the third concept, and these are the second concept as per the internal resisting moment, internal resisting method. The result will be same. If you go to the first method, first concept, this is the first concept. The result of the remain same 5 seconds. So you can see that all the results are same. Okay, so let's go to another example. Where this is the another example for the concept 3. We have been taking another extra example, and the prestressing tendon in located in figure below, and the produce the effective prestress which is 1650 mm. Analyze the beam using load balancing method, which is the concept 3, to get the external fiber at the mid span. So this is the mid span. So we can see 35, and the E value is given 150 mm and 10 meter is in length, and the dimension all that's given here. So E is given, O is given, S given, A given, I. We have been found I. For applying balancing method, we are using this formula, and this is the important how we calculate the M. We know the MW is for the 8, but W is the W ultimate. So I will calculate W ultimate. W ultimate is total W minus W balancing. So I will calculate W balancing. W balancing is FEW divided by L square, and found 12.6 kilonewton per meter. So as if we get the W balancing, then we will deduct the value from total W, as we know that W is given 35. So if you deduct the balancing at 35 minus 12.6, then we will find 22.64. Then we will put in this value as a simple subtract beam. W is equal to 8, and finding the moment. And after getting the moment and putting this moment is here, and ultimately found 25.4 at the top surface, and the bottom surface will be positive is 13.2. Okay, let's see another variable example of variable section, which is the I section is given here. So let's see a simple supported prestress tension prestress concrete beam is loaded with the uniform live load is 55 kN/meter, and exploding is self weight as shown below. This is the kilo, and location of the prestress is 1623 km. Calculate the external fiber stress loaded balancing method. So this is the balancing method. What does mean? This means the concept of 3, and the shown the distribution at the mid span. So it will be calculate this mid span, and the given the concrete unit at MB and B2. So and T1, T2 is in CGS, which is CG of steel and L. So you can see here E12 is given, CG is given, as you can see these are the given 115, and L is given for length of the beam is 12.9, and this dimension is also given here. B1 is given 900 and 150 is given 720 is given, and 150 is given, and this is the dimension also given. So let's start. So we are dividing this section. I section is 3 categories, 1, 2, 3. So we are taking the A1, A2, A3, and Y1, Y2, Y3. I will calculate the total Y. This is the Y bar. This is the CG of Y, A1, Y1, Y2, Y3, Y3 plus A3. And for 6 is 119 from the bottom. This is the Y bar. And how we calculate I? The as usually by 12, and it will be adding some y square. Oh, what is the a? Is nothing but 270 into 150 and 6 is minus 75 square. As we can count, 75 is given here, and total y bar into we can count 6 is 6, and 270 there is the 725 sorry 270 is here, 270 and 150 is given A1, the section of A1, and found is A1, and in the same way I and we are summing the all the I1 I2 I3 which is 3. Now we'll calculate the E, which is E by H by 2 into CGS, CG of steel, and H will be found 270 as given in question. 270 is the 270, and in this way I found E value is 20 and Y value will be found here at the total, and now we are doing balancing method this here. So it will be important of M will be important, W ultimate will be W balancing will be 8 F EWL square, and found E. And if we deduct the total UDL minus W balancing, and it will be found W ultimate. So if we putting here W square 8 as a simple support, and found this value for moment ultimate, and putting this value in here as a stress for force per area into minus MI by R, and found 30 minus 30 31.5 at the top and 19.5 at the bottom for I section. Okay, so we've been seeing here. So I hope that these are the concrete. So now we'll see the classification and type of the Prestress concrete. Here the classification and type of Prestress concrete. So we've been seeing external or internal Prestress. So these are the jacketing we've been seeing here. Linear or circular Prestress, as we've been seeing. The linear Prestressing is often employed to include all the other structure. Here the circular, which is the water tank, which is they apply to the Prestress circular structure, where the Prestressing tendon are wound around the circle, and it is known the circular Prestressing. And the pretension and post-tension, we will see this is the pretension, and this is the duct, and after the this is the prestension. Now we will see this is the diagram prestension. Before the casting, the jacketing is here, the tensioning is applied before the casting of the RC. After the casting RC, it will be like this. So the tension is given here. What is the post tension? The concrete is casting, but the duct is given here, and by inserting the cable on the duct, and the tensioning after the casting of the concrete, it will be post tensioning. So here tendon are tension before the concrete phase. So this is the tendon are tension before the concrete phase. It will be tension. So tendon are tension after the concrete phase. After the concrete phase, we will feel the tendon is placed. So you will see in anchor and not into anchor. When the post tension, the tendon are anchored at their end by means of the mechanical device to the transmit to the Prestress to the concrete, and then the free tension, the tendon have their Prestress transmitted to the concrete by their bond action near the end. And number 5, bond and unbonded tension. Bond denoted by the bond through their length of the surrounding concrete, and the unbonded tension is grazes and work with the proper and plastic material to prevent the bonding of the surrounding concrete. So precast, number 6, precast, casting place and composite construction. So Precast involve in placing of concrete from its final position, and the member of being cast in side place is known the casting place, and precast part of the member erected and then removing position in place is known the composite construction. And number 7, we can see partial or full prestressing. So partial prestressing in service load is under of service load. So MS used, and fully prestressing service it is constructed under the service load, but the mild steel road has not used. When the material is designed the material is designed so that under the working load where no tension stress in the grip, and the concrete is said to fully prestressed. And some tension will be produced in the member under the working load, then it will be termed the partial prestress. Okay, so I have the classification of type of PSC is completed. So now we see the stage of loading of Prestress. Stage of loading. So let's see here. So if you want to the classification of type in depth, then you can go to the TY link book and first page. Then you can click here external Prestresses here, and the linear and pre-tension, post-tension, and bonded, unbonded, casting press, partially prestressed. And now we'll do the loading stage. Okay, so let's see what the loading stage. Initial loading. This is the last topic of the today's lecture. Loading. The initial loading. Prestress. Initially, prestress has some forces. The member or structures under prestress but is not subjected to any superimposed or external load. Second one, in an intermediate stage. What is this? It is come from during the transporting, when the train or it is carrying or lifting during the lifting time. This stage is during transporting and erection. It occurs when transport to the site and erect in position. That's the final stage. Final stage is the stage when the accurate working load comes on to the structure. These are the 3 stages. If you want to read this deeply, then you can go to this TO link and farming. This is the initial stage. You can see the initial due to tendon. It will be 80% or 95% of stress, or 70% of and the immediate for distension and service load. So during the prestressing or transforming prestressing, the intermediate stressing area and the final stressing area also all are given here. If you want to see, then you can go to this book. All the concept is given here. All the parameters are also given here. Okay, so I hope that today's lecture has in depth you can understand everything. And the summary here. The firstly, I define the prestress and then compare what is good difference between comparison between RC and Prestress concrete. And this is the 3 type of concept: the first, second, third. So all we have been seeing all the dimension of the beam and usually same, and the top stress and bottom stress all are the same. We have been found in the 3 concepts. The first concept. What is the first concept? First concept is the prestressing transformation into elastic material. What is the second concept? Prestressing combined high strength river into concrete. And what is the third concept? The prestressing achieve the load balance. So all the are same. Everything same concept. Okay, so if you have and then classification of the prestress concrete and stage of loading everything. So if you have any question, then you can ask me without doubt, and I will see here. I will just here classifying here. these are the definition, and these are the difference between Prestress and RC. Why Prestress is better, we can see here. And then we've been doing the first concept of Prestressing transformation into elastic material, and we've been seeing how to stress is coming here, load stress and moment stress when the concentric tendon and the eccentric tendon, then it will be force tension, force stress and moment stress, and it will be coming from the eccentric stress also, and founding this equation also. Okay, then we've been seeing the example of the first concept, and found the top and bottom we've been found here. We've been seeing here the F is minus, always minus. Why? Because it is the Prestress, it is tension before the casting, that's why it is always minus during the Prestress concrete. Minus A by minus F by M by L, and we will found this billion top and bottom stress. We will found the first concept, as we can see the first concept. The dimension is UTL, and the stress at top and bottom is found here. And we've been another example we've been seeing here. The stress is taken from 2 meter away from the support and forming this value. We're just checking what will be changed. And then we can go to the second concept, the internal resistance couple method. We've been using this method, and the dimension of the remains same, the 45, 7.3, 500, 700, and 45. So this is second method, 7.3, 575, and 45. That remains same. All the dimension remains same. If it remains same, the what will be answer? The answer will be same as 5.3 at top and 2.94 at the bottom. 2.7 and 2.5. Okay, same. Okay. And then we will go to the third concept, achieving the balance load. So we've been getting the balance load as the same load, 7.3, 45 kilonewton per meter. 7.3 is the length, and 575, 750 is the third concept we've been using here, and the load and the final stress at top and bottom are just the same as the previous. But the difference is how we calculate the tableau balancing, and we will deduct the tableau balancing to the total tableau that is found on the ultimate tableau. An ultimate tableau from tableau is the simple setup. Okay, so we've been found all these parameters here, and we've been seeing another example for 3 and another example for concept 3. And then we've been seeing the classification type of the Prestress concrete. So there are the different classification. Number 1, external, internal, pre-tension, post-tension, and pre-dent correspond and Prestress, casting plus composite, and partial proof, and full Prestressing. And then finally the stage of loading of Prestress. Initial stage. What is the initial stage? It is nothing but the member of structure is under the Prestress, but no subjected to any superimposed load. But that means there is no live load, there is no moving load. The intermediate stage, but this stage is during the transporting and erection, and it is occur when the transporting site and erected in position. Final, what is the binary position? The final position stays when the actual working load come on the structure. These are the previous lecture. I hope that you can understand. Thank you everyone for the questions.